Hey, iqkid here to cover indefinite integrals. So to start, let's write the general function f of x is equal to ax to the n. Okay, so with that general function, the antiderivative is capital F of x. So that way you have f of x is equal to the derivative of that. So basically it's as if you're finding the function of which the derivative is f of x. Okay, so another term for this is the integral. So when you're taking an integral, the general form is going to be more like this, and this is in terms of the antiderivative, so in terms of capital F of x. So the integral of f of x dx is equal to capital F of x plus c, where c is a constant. Okay, so some things about this equation right here, this equality. This symbol right here, that is the integral symbol. Okay, and then f of x, the part within the integral between the integral symbol and the dx is called the integrand. And then dx indicates the end of the part being integrated. Okay, and then x is the integral variable, or integration variable. So later on you will use other variables to in an integral, and so this is just saying in this case it's x, but you could have, say, f of y dy, and that'd be taking the integral of a function based around the variable y. Okay, so as I said up here, c is the constant, and yeah. So now let's look at what this actually would look like, the math behind it. So when doing indefinite integrals, you want to use the following general form. So f of x dx, as before, is equal to 1 over n plus 1 times ax to the n plus 1, and then plus c. So that's your constant. So something to note about this is many problems will just say integrate instead of indefinitely integrate. Say integrate instead of indefinitely or definitely. And in the problem, you can tell from the context. So if it gives you endpoints, a start point and an end point for the integral, then you know it's definite, and I'll get into that in another video. but basically if it doesn't specify, or if you have no idea if that there should be a start or an end to it, then there probably isn't. So basically right now, don't worry about it. So if it's like that, so look for context clues. Okay, now let's look at the properties of an indefinite integral. So if you have a constant within the integral, where k is any constant, then you can take it out of the integral. It's not going to change anything by having it in or out. If you look at the function right here, a is a constant, so you could take a out and it's not going to change anything, because you're still going to be multiplying by a. So yeah. The second property is that if you have two separate functions being added within an integral, you can split it. You don't actually have to put these brackets here. I just put it to make it clear that those are within the integral. So if they're being added or subtracted, as long as they're not being multiplied or divided or anything, then you can split them up into two separate integrals, and that'll help you integrate them. Okay, and then also the last one is the derivative is, or the integral of the derivative is the base function. So basically you can think of this as a derivative as going a step forward, and then an integral as going a step backwards. So if you go a step forward by doing the derivative and then a step backwards by doing the integral, then you're where you started at. Okay, so now let's do an example. So in this example, we are to take the integral of this function right here. F of x is equal to 3x squared. So to start, let's write the formula. So the integral of f of x dx, you gotta remember the dx, because that tells you what you're integrating, basically. If you never put a dx, it'd be assumed it was the whole thing. So it's equal to 1 over n plus 1 times a x to the n plus 1 plus c. Don't forget c. It's really easy to forget, and you'll get points taken off if you forget it. Okay, so step 2 is to identify the pieces. So a is 3 and n is 2. And you know that by looking at the general function, the ax to the n. So ax to the n. Okay. So now let's go on to step 3. In step 3, we are going to go ahead and plug in. So we have f of x dx is equal to 1 over n, which was 2, plus 1 times a, which is 3, x to the n plus 1, and then plus c. Don't forget this. Don't forget. Okay. And step 4 is to simplify and then check your work. So f of x dx is equal to capital F of x. You don't actually have to write this part, but it's shorter to write than that, so you can. So then that's equal to 1/3 times 3x cubed plus c. Okay, so then capital F of x is equal to x cubed plus c. And that's your final answer. Alright, now let's check our work. So we can check our work by taking the derivative of this, and if we get this function right there, the f of x, lowercase f of x, our starting function, then we got it right. So let's check our work. F prime of x is equal to 3x squared, and the plus c goes to 0 since it's a constant. And so then f of x was equal to 3x squared, so those are equal. So therefore capital F of x equals x cubed plus c is the indefinite integral of lowercase f of x is equal to 3x squared. Okay, so let's go ahead and do another example. In this example, we are going to again take the integral of this function. So this one's a little more difficult because it has more than one variable, or more than one of the variable. It doesn't have multiple variables. So it has more than one x. So 2x cubed plus 7x plus 5. So let's start by writing the formula. So the integral of f of x dx is equal to 1 over n plus 1 times ax to the n plus 1, and then plus c. Don't forget plus c, it's very important. Okay, so let's go on to step 2. In step 2, we are going to identify the pieces. So I'm going to write the starting function again, just to be able to link the pieces. So I'm going to put a parentheses 1 for the exponent, because that's what it is, and then 5 paren x to the 0 paren. Just so you see what every term is. So let's start with a1 is equal to 2, n1 is equal to 3, a2 is equal to 7, n2 is equal to 1, a3 is equal to 5, and n3 is equal to 0. Okay, so let's move on to step 3. In step 3, we are going to plug and chug. Okay, so let's go ahead and plug in. So f of x dx is equal to 1 over n1, which is 3, plus 1, times a1, which is 2, x to the n1 plus 1, and then you add the next part. So it's these, you could treat these as separate functions, really. Each part that's being added, so you could treat this part, this could be 1, this could be 1, this could be 1. You're basically taking the integral of all three of those separately. You just don't actually have to split it up. It's doing the exact same thing either way. So the next part is 1 over n2 is equal to 1 plus 1 times a2 is equal to 7, x to the n2 plus 1, and then plus a3, or plus 1 over n1 or n3 is 0 plus 1 times a3 is 5 x to the n3 0 plus 1, and then plus c. Don't forget plus c. Okay, so now let's go on to the next step, which is to simplify and check. So the integral of f of x dx is equal to, I'm not going to bother writing the capital F. You don't need to. You can just continue writing this. I just did it the first time so that way you'd know. Okay, so let's simplify. 1/4 times 2x to the 4th plus 1/2 times 7x squared plus 1 over 1 times 5x to the 1st plus c. Don't forget plus c. Okay, so then f of x dx is equal to 1/2 x to the 4th plus 7/2 x squared plus 5x plus c. And this is your final answer. So to check, we're going to take the derivative as before. So the integral of f prime of x dx, or really what we're doing is, this is what we're really looking at, is d over dx of the integral of f of x dx. That's what we're really looking at right here. Okay, so that's what that is. Okay, so that is the derivative of this would be 4 times 1/2 x to the 4 minus 1 plus 2 times 7/2 x to the 2 minus 1 plus 5 x to the 1 minus 1, and then the c goes away because it's a constant. So then I'm going to write it like this because technically this is correct. So the derivative of the integral is equal to 2x cubed plus, those cancel, so 7x to the 1st and then plus 5. So f of x, our starting function, was equal to this, so 2x cubed plus 7x plus 5. So those are equal, so we're good. So therefore, this is the integral of this function right here. Okay, so now let's do one more example, and I'm going to make this one a little different, just so that way I'm hopefully covering any questions y'all will end up having. So in this problem, in this example, we're going to take the integral of the derivative, but it's worded in a way that might confuse some people. So given the derivative f prime of x is equal to 6x cubed plus 12x plus 2, find the function f of x. So we already know that the integral is the same thing, the integral of the derivative is the same thing as the base function. So that's, in fact, that's one of our properties right there. So we can go ahead and start. So let's start by writing the formula. So I'm going to write the formula that I gave you where it was f of x dx. In this case, our f of x is actually f prime of x. But this is just saying the base function. This is our base function in this case. You can really treat this as f of x, and this is capital F of x. It's the same thing. It's just they want to confuse you and make sure you know everything you're doing. Okay, so then that's equal to 1 over n plus 1 times ax to the n plus 1, and then plus c. Okay, so in this case, our integrand is f prime of x. So you might want to make note of that if you're taking notes, because that might be kind of confusing. Okay, so step 2 is to identify the pieces. So I'm going to rewrite the starting equation. F prime of x is equal to 6x cubed plus 12x plus 2. Okay, so then a1 is right here. So a1 is equal to 6, n1 is equal to 3, a2 is 12, n2 is 1, and then x to the 0 right there. So n2 is 1, a3 is equal to 2, and n3 is equal to 0. Okay, so now let's go on to step 3, which is to plug and chug. So let's go ahead and do that. So the integral of f prime of x dx is equal to 1 over 3 plus 1 times 6x to the 3 plus 1, so 1 over n plus 1 times, so that was n1, and then times a1, which is 6, x to the n1, 3 plus 1. So then plus the next part, 1 over n2, which is 1, plus 1, times a2, which is 12, x to the n1, which is 1, or n2, which is 1, plus 1, and then plus 1 over n3, which is 0, plus 1, times a3, which is 2x to the n3 plus 1, which is, so it's 0 plus 1, and then plus c. Don't forget that. Okay, step 4 is to simplify and then check our work. So the integral of f prime of x dx is equal to 1 over 4 and times 6x to the 4th plus 1 over 2 times 12x squared plus 1 over 1 times 2x, and then plus c. So don't forget that. So if you remember, the integral of the derivative is the same thing as the base function. So we can write that f prime of x dx is equal to f of x, and that's equal to, let's continue simplifying. So 3 halves x to the 4th plus 6x squared plus 2x plus c. So this right here is your final answer. Okay, so then now let's check our work. So to check our work, we simply need to take the derivative of f of x. So f of x, and put that in brackets, and d over dx. So that means we're taking the derivative. So that is equal to, let's see here, 3/2 x to the 4th. So that would be 4. So n times a n to a x to the n minus 1. So 4 times 3/2 x to the 4 minus 1 plus 2 times 6x to the 2 minus 1 plus 1 times 2x to the 1 minus 1, and then the c goes away because it's a constant. Okay, so then that's equal to, I'm going to continue writing as d over dx so we can differentiate between f prime of x and the derivative of f of x when checking our work. So that's equal to 6x cubed plus 12x plus 2. And so then let's see if that's equal to f prime of x. So let's look at our original function, which was this. So it's equal to 6x cubed plus 12x plus 2. So we are good. So therefore the integral of so therefore f of x right here, this right here, is the integral of f prime of x. So I hope y'all enjoyed, and I hope this was helpful. I know a lot of y'all probably have AP exams coming up, or if you're in college you have finals coming up fairly soon, and you're probably covering integrals right now, or if you're just looking back, or even if you're not to calculus yet, you're trying to look ahead, kudos to you. I hope this helped. I hope this answered what you're looking for. And yeah, so have a wonderful day. IQ Kid signing off.